right, today we're going to continue with our patterns unit. Our big idea continues to be describing patterns in tables and graphs can help solve problems and describe the world. Today we're going to work on describing the table by telling the rule, and we've touched on this a little bit: input to input rules, output to output rules, and input to output rules. So it's the three different ways that we're going to concentrate on today. All right, so we can draw pictures to show the relationship of a table in values. In this table here, we are actually representing this pattern here that we see in these figures. The input is the figure number, and the number of triangles is the output. Now, I would rather than have input and output here, I would make this figure number and this one number of triangles. Just for clarity, it makes it more clear as to what that is. Regardless, in figure 1, there is 1 triangle. In figure 2, there are 4 triangles. In figure 3, there are 7 triangles, and so on. We can use a rule to describe the relationship between the two columns in the tables of the values. This pattern rule tells us the numbers and operations in the input-output machine. As you can see, the input to input pattern is increasing by 1 each time, starting at 1. The output pattern is increasing by 3 each time, starting at 1, as you can see. Now, trying to figure out the input to output rule is always a little bit more tricky. Sometimes this output to output rule can help you figure out and give you a clue as to what to do. So for example, we need something that has to do with 4, because we can see here that for the output to output rule, it's starting at 1 and adding 4 each time, and that's kind of a clue. So you start with 4 as your first number in your input output machine, or in your rule, and I would start with times in this case. You could start with adding, it doesn't matter, but it's going to be something with 4, adding, subtracting, multiplying, dividing, whatever. So we're going to go times 4, and if we look back in our table, 1 and 1 is tricky to work with, but the second numbers in the table were 2 and 5. So I'm going to work with those because that's easier. So 2 times 4, well, is 8. So to get to 5, I'm going to have to subtract 3. So I'm going to make my pattern rule times 4 minus 3 and see if that works. Remember to double check. You should have to have at least 3 that are going to work in order for that to be the case. All right, now let's check if our input to output rule of multiplying by 4 and subtracting by 3 does in fact work. So times 4 minus 3, that was input equals output as our rule. Let's determine if that actually does work. We tried 2 times 4 minus 3 equals 5. Let's try 3. 3 times 4 is 12. 12 minus 3 does equal 9. 4 times 4 is 16. Minus 3 is 13. So it does work for 3 of them. And once it works for 3 of them, it has to be at least 3. Then you know that that rule does in fact work. All right, now you get to do some practice. Each table shows the input and output from a machine with 1 operation. So these are 1-step problems, not 2-step like the one we just did. Identify the number in the operation machine, continue the pattern for the next 4 input-output machines, and then write the rule that relates the input to the output. So you're looking for the input to output rule. Make sure you read those questions carefully. So you need to extend by 4 and then write the rule that is for the input to the output. Press pause now and try that for just A and B to begin with. All right, let's take a look at our first one, A. Using the output to output rule, I'm going to see if that's going to help me. Well, 7 to 14 is plus 7, plus 7, plus 7. So I can see that that is the plus 7 rule here. So I'm going to see if I can use 7 in some way to get from the input to the output, because that's the rule that I need eventually. So input to output then, well, I can try, let's try times 7. So 1 times 7 is 7, 2 times 7 is 14, 3 times 7 is 21, and I can see that that one's actually pretty easy. I've been able to find that one fairly quickly. So my pattern rule that relates input to output then would be input times 7 equals the output. The next 4 numbers, well, 5, 6, 7, 8. 5 times 7 is 35, 6 times 7 is 42, 7 times 7 is 49, and 8 times 7 is 56. Let's take a look at B. Output to output, it's only subtracting 1 each time. So, that's not actually overly helpful. So I'm going to have to see what else I can see here. 50 to 39. What could I do to get from 50 to 39? Well, I notice that the number is getting smaller. So I'm going to try something with either subtraction or division. I'm going to try division first. 50 divided by 2 is 25. Nope. And I know this is only a one operation rule, so I don't really have to try a whole lot more. How about I try subtracting something? Well, 50 minus 10 is 40, so 50 minus 11 would be 39. So let's try minus 11. 50 minus 11 is 39. 49 minus 11 is 38. 48 minus 11 is 37. And 47 minus 11 is 36. Perfect. So I found my rule. My rule would be input minus 11 equals my output. And then extending the pattern, counting down by 1 on the input. So 47, 46, 45, 44, and 43 would be my next 4. And you can actually see it's also counting down by 1 on the other side too. So this one is a little bit easier. 35, 34, 33, 43 minus 11 is 32. Now the other two, let's give those two a try. Press pause and try those two now. Alright, so I'm going to try my output to output to see if there is a hint there. 20 to 40 to 60 to 80, that's 20 each time. So I'm going to try that as my hint. 2 times 20, because I know this pattern is getting larger, so I'm going to try a multiply and add 1 first. 2 times 20 though would be 40, so that's too big. 2 plus 20 would be 22, so that's too small, unless I went 2 plus 20 minus 2, but I know these are one-step rules, as it told me up here, so that's not going to work. So I'm not going to use my 20 anymore. I'm going to try something different, because it came to my mind that perhaps it looks like it's times 10. As I see, I've added a 0 each time, and we've learned with annexing zeros over the years that when you add a 0 to the end, it's really times 10. So let's try it. So 2 times 10, yep, that works. 4 times 10 is 40, 6 times 10 is 60, and 8 times 10 is 80. So our input to output rule is input times 10 equals output. Let's take a look at D. Input to output, 500 to 485. Well, what do we see is happening each time from 485 to 435? Well, it looks like it's subtracting 50 each time. 500 to 485 is getting smaller, but you're certainly not going to divide by 50, because that would make it much too small. Subtract by 50, 500 minus 500 minus 50 would equal 450. Which doesn't work either. So I'm not going to try my output to output rule as a hint in this case. I'm going to take a look. 500 to 485, what would it be if I subtracted? Well, let's see, 500 minus 485, well, it's 15. So can I subtract 15 each time? 500 minus 15 equals 485. 450 minus 15 does equal 435. Oops, 15, sorry. 400 minus 15 does equal 385. There we go, we have our rule. So our input to output rule is minus 15. Now the biggest key when looking for rules is that it's okay to try it and see if it works, and if it doesn't, move on. Try another one, try another one, try another one. Sometimes you're going to have to try lots of them until you finally get the correct rule. Now what I would recommend that you do is write down what you've tried. So for example, for this last one, we tried plus 50, or actually it was minus 50. We tried minus 50, it didn't work. We tried divide by 50, well, at least considered it. We realized that didn't work at all. Then we finally tried minus 15, and that one worked. But if you have a record of all of the ones that you've tried, and if you're truly stuck, and you've tried at least 7, 8, 9 different things, at that point, as long as you have this evidence of your efforts, and you tell me you're completely stuck on one pattern, that's okay. It's not a problem. There are some patterns that will kind of stump us, and I will be able to help you through those, or a partner will be able to help you through those. But you do need to have the evidence of the effort of what it is that you all tried. And of course, I would highly recommend for this unit that you do use your calculator, because you don't want to try a pattern and then realize, yeah, that pattern actually worked. It was just my calculations that were incorrect. And because you're having to try so many different things, calculator is a really good tool to use just to help everything go a little bit quicker. All right, on to your concept practice. Math makes sense, number 14, page 14 and 15, numbers 2, 3, 4, and 5. Number 3, when you're drawing your pictures, you must increase in a regular and predictable way. So when you're drawing your pictures, say for example, I had a pattern, that was 1, 2, 3 figure number, and it was 4, 6, 8, for example. Say I started with my figure I drew was like this, and I'm going to add 2 for the next picture. I'm going to add 1 up here and 1 up here, and then when I draw my next one, it has to be predictable in the way that I'm going to add them. Well, last time I added 2 here, so I'm going to add 2 here again. Okay, so it has to be predictable the way you draw it. All right, give it a try. If you have any questions, make sure you ask.